Hello, my dear students. This is Felix Balaji. Today, let us discuss a problem based on NLM with friction. In this situation, it was given a block C kept on a smooth table. Above this, we have two more blocks A and B are given, connected with a string through a pulley. Now, the coefficient of friction between the two blocks is mu. Between A and C mu, between B and C also mu will be there. The minimum and maximum force that can be applied in order to keep the smaller block at rest with respect to bigger block. That means these two blocks should be rest with respect to bigger block. So for that, what is the minimum force required and what is the maximum force required, he was asking. Now let us find minimum force required not to slip. It was given once again A and B are rest with respect to C. That means the whole thing is moving with same acceleration A due to some external force F. So for the whole system, acceleration equal to external force F by total mass m plus 2m. If the whole system is having acceleration A, then upper bodies will have pseudo acceleration A, pseudo force ma. Even for this also, pseudo acceleration A, pseudo force ma. Now let us take free body diagram of A block and B block. For B block, gravity will be downwards. Tension acting on the string. Due to gravity, this block will have tendency downwards. It was a friction F2. Even for this block A also, gravity downwards, normal reaction N1 with the floor. So here we are having pseudo force. It is having tendency right side due to this B block. So friction will be left side here F1. As B block moving downwards, then A block will have tendency to go right side. Here the question was, what minimum force we should apply so that this acceleration will be minimum, so that this will be minimum, so that this A block will not move right side and this B block will not come down. That was the meaning of this one. Now let us try to understand. So what is a minimum force meaning? For a particular minimum force, that means for a particular minimum acceleration, that means for a particular minimum pseudo force, so this will be stopped not to move right side. This will be stopped not to come down. So that minimum force you are asked to find. Now free body diagram of B block. Here upward force T plus F2 balanced with mg. So for ready to sleep, this F2 becomes maximum. So maximum from formula mu into N. Mu into here normal force N2. Here N2 is balanced with MA here, so we can replace N2 value as MA. Let it be equation number 2. Now let us take free body diagram of block A. Here gravity mg, normal force N1 balanced with mg here. Right side force T balanced with MA plus F1 because it is a rest with respect to block C. Now T balanced with MA plus F1. It is also ready to slip case, so F1 should be maximum here. Here remember carefully, we are applying minimum force, that means minimum acceleration you will be having, not to slip right side, not to slip downwards. That means in ready to slip case, we should take this friction maximum only. Now Fs maximum formula was mu s into normal reaction. At this point normal reaction is mg here, substitute as it is there. Now this will be equation number 3. Now put this 3 T value in equation 2 here. Then you will get equation like this. From this, if you write A as subject, you will get acceleration. From equation 1 we know acceleration equal to F by m plus 2m. Substitute this A value here and write F as subject, this will be your minimum force required not to slip. Same we should repeat for maximum force required not to slip. If we increase this force value, then this acceleration will increase, then this pseudo acceleration will increase, pseudo force will increase. Due to that, this whole system, this A block will move left side. Now this B block will have tendency to move upwards. So this tendency was opposed by friction right side. That only I had shown here. Here also A block and B block are rest with respect to C given. Then the whole system acceleration equal to total external force by total mass m plus 2m. Now free body diagram of B block. T balanced with F2 plus mg. Here ready to slip case, so friction will be maximum. So here mu into normalization N2 is balanced with MA. You can see here. Equation 2. Now let us draw free body diagram of block A. Here right side force at T plus F1 equal to left side force MA. You can see this one. T value we know in this equation, substitute here. Friction is maximum here, so mu into N, so mu s into here normal force N1, N1 balanced with mg here. You can see mg here. So everywhere m cancel, get acceleration. Substitute this acceleration in this first equation and you can write F as subject. It was the maximum force required not to slip. Thank you.